Okay, so today we're going to talk about a little bit more complex balancing with chemical equations with algebra, and then we're going to talk about how to do it with matrices instead of algebra. So we're going to begin as we always do, where we put our variables in front of the different compounds. And then we're going to write equations for each of the elements in the compound. So let's see, we want chromium, sulfur, oxygen, and hydrogen. Alright, so chromium, you take the number of that element, so we have 2 here, and then you're going to multiply it by the variable in front, right? So we've got 2a. We don't have any chromiums in this B term, so we won't put that. The arrow is like an equal sign, and so then we have 2 chromiums in the C term, and then there are no chromiums in the D term or in the E term, so we leave those off. Now hopefully you can see that because there's 2 on both sides, that cancels out, so really it's A equals C there. Okay, so then we can do sulfur's equation. So there are 3 sulfurs in the A term, then we have 1 sulfur in the B term, and we have 3 sulfurs in the C term, we have 1 in the D term. Okay, oxygen. We have 9 oxygens in the A term, we have 4 in the B term, we have 12 in the C term, we have 2 in the D term, and we have 1 in the E term. Alright, and then finally hydrogen. We have 2 in the B term, and we have 2 in the E term. And since they both have 2's, that goes away, so it's really B equals E. Alright, so the next thing that we're going to do is list all of our variables over here to the side. And you can pick any variable you want and set it equal to any number that you want. So let's see, how about we say A equals 3, and that means C has to equal 3, so we just used up chromium's equation. Now if you look at all of the other equations that we have here, there's a A and there's a C. We know both of those, but I don't know what B or D is. So that's 2 unknowns in the same equation, which means I can't solve it. I have an A and a C here, but I have B, D, and E. That's more than 1 unknown in the equation. I can't solve that. And here, both of those are unknown. I can't solve it. It looks like I'm stuck. So what we're going to have to do is make a substitution. Now, we've never had to do that before, but this equation is a little bit more complex than any of the ones we've done before. So I want you to know how to tackle it in case you run across something like this in the future. At this point forward, this is just algebra. There's no chemistry here. This is all algebra. So let's see. If B equals E, then I can substitute that equation into some other equation. So in oxygen's equation, I have 9A plus, normally we would say 4B, but since B equals E, I'm going to change that to 4E instead. And that equals 12C plus 2D plus E. So I've gotten rid of the B variable in there, and now let's see, I can subtract an E from both sides. So that gives me 9A plus 3E equals 12C plus 2D. And you're like, okay, but now you only know one thing and you have three unknowns in that equation now. That's alright. We're going to do another little algebra trick here. I'm going to take sulfur's equation, which we have, let's see here, 3a. And in sulfur's equation, you see there's a b as well, right? It says plus b right here. I'm going to substitute again, and I'm going to change that into an e. So I'm going to say plus e, 1e, equals 3c plus 1d, okay? So these equations now only have the same variables as each other, and I'm going to do an elimination with them. So I'm going to multiply this bottom equation here by -3, and then I'm going to add those equations together. The reason I'm doing that is because when you do -3 times +3a, you're going to get -9a. When I add these equations together, that means that the -9a and the +9a will cancel out. Then I'm going to get a -3e. When I add that to this +3e, they too will cancel out. So on this side I have 0. So 0 equals, alright, let's keep going. So let's see, if I do -3 times +3 over here, I'm going to get -9. And if I add 12c to -9c, then that's going to give me +3c. So let's put that here. Plus, alright, finally, I'm going to do this -3 times 1d. That's going to get me -3d. If I add -3d to +2d, then that's going to give me -d. Okay, so let's see here. I can take this d and I can move it to the other side of the equal sign so that my new equation is +d equals 3c. Okay, so now I can go back to either sulfur or oxygen's equation, and I can make another substitution because I know that d is just 3c. So let's look at sulfur's equation, okay? Sulfur's equation is 3a plus b equals 3c plus d. Okay, so let's see here. I know what A is and I know what C is, and I chose 3 for both of those. And I know that D is the same thing as 3C, right? So that means that I have 3A plus B is equal to, so let's see, I have a 3C right here, and this is also 3C. That means that I have 6C over here, right? So I can go ahead and plug in my numbers. I know that C is really 3, so that's 6 times 3, so that's 18 on this side. And A is also 3, so 3 times 3 is 9, so I have 9 plus B equals 18, so I can go ahead and subtract 9 from both sides, which means that B is 9. Okay, so that's good. We've gotten closer now. B is equal to 9. And remember this original equation for hydrogen, whatever B is, that's what E is as well. So that means that E is 9. Okay, and so the last thing I need to know is what's D? Remember, D is 3 times C, and C is 3. so that means that D must be 9. Okay, so we have all of our variables figured out, but they're not in their lowest whole number ratio, which is a requirement. So we need to go ahead and reduce that by dividing everything by 3. So that means we get 1, 3, 1, 3, 3. Okay, and those are our balancing coefficients. All right, so yeah, we had to do a couple of steps. We did some substitutions, some eliminations. We could have done the whole thing with substitution or the whole thing with elimination. It, really makes no difference. But we use both of them to kind of help review those concepts and make our lives a little bit easier. All right, now let's see the rest of our semester. We've got, like, you have to know how to do nomenclature so that you can get from the formula or the name to the formula. Then you have to know how to predict reactions. Then you have to know how to balance the reaction. Then you have to know how to do the stoichiometry. And then if it has something to do with gases, you have to do gas laws. There's a lot of stuff that could go into just one problem. We may not have time to sit here and go through all of this algebra to balance the equation. So I'm going to teach you how to balance an equation with a matrix instead, and let your calculator do the work for you. Alright, so let's see, how are we going to do this matrix thing? You're going to do exactly what you do for algebra. You are going to write your formula down. You're going to put your variables in front of that formula, just like you always have. You're going to write an equation for each element in the formula, just like you always have. Okay, all of that stuff is the same. What's a little different, however, is that these equations down here, okay, when you write them, we want to write them in standard form, all right, which means everything is equal to 0, okay? And we also need to include every variable in every equation, whether it's supposed to be there or not, okay? So let me put that again. Standard form, which means equals to 0. And we include every variable in every equation. Let's get an example of what that might look like, okay? And whatever, let's see, whatever order you write it in, that's the order that you need to write it in the entire time. And by order, I mean like, A, B, C, D, okay? So let's see. We're going to write chromium's equation together. So you'll see up here that for chromium, we had A equals C, right? But what we're going to do is we're going to write 1A plus 0B, okay? Remember, we have to include every variable in every term, even if it's not normally there, right? So we're going to put 0B. Also, since everything has to be equal to 0 and the C term is on the other side of the equal sign, we're going to have to subtract C to the other side so that we can set that equal to 0. That means that down here we're going to write minus 1C, okay? We also need to include D and E in this equation because we have to include every variable. So we're going to say minus 0D minus 0E. I'm putting minuses because D and E were on the other side of the equal sign. It really doesn't matter because they're zeros, so we could have said plus 0D and plus 0E. That makes no difference. And then, of course, all of that's going to be set equal to 0. Okay, so this is chromium's equation. Let's see if we can do sulfur's equation in this form. Okay, so up top there we have 3a plus b. Alright, so we're going to write down 3a plus, we're going to put the 1 in front of the b so we have an actual number. So we've got 3a plus 1b. And instead of saying equals 3c, we have to subtract the c and the d term over so that everything is equal to 0, right? So that means we're going to have minus 3c and minus 1d. And then there's no e there, so we're going to say minus 0e. Okay, now let's do oxygen's equation. So we've got 9a plus 4b minus 12c minus 2d minus 1e equals 0. And then hydrogen, there's no a, so I'm going to put 0a plus 2b minus 0c minus 0d minus 2e equals 0. Now I could have just put plus 1b and minus 1e, which we could go ahead and do. Like let's go ahead and change that to 1s right there, just to keep everything simple. So 1b and 1e. Okay? This is almost our matrix. It really is. We could rewrite it in a different form, but I want this to be a very quick process for you. So instead of originally writing your equations in this form, if you know you're going to do a matrix, see if you can't just write it in the standard form that we have down here below right from the beginning. Okay? If you can do this straight away, you know, right from the equation, then that'll speed things up a bit. Okay, in order to do a matrix, you need to know what the dimensions of your matrix are. And what that means is how many rows are there and how many columns are there. Okay, so you have 1, 2, 3, 4. You have 4 rows. Okay. And then you have, let's see here, you've got 1, 2, 3, 4, 5, 6. Okay, you have 6 columns. So this is called a 4 by 6 matrix. Notice that the 0 over here is included. Alright, that is a column all on its own. Okay, this is a 4 by 6 matrix. Alright, so now let's see how are we going to fill in that matrix. Every number, okay, every single number in this row, or in each of these rows, that's going to be some numbers that you're going to fill into a grid. Okay, and that I'll tell you how to do that on your calculator here in just a second, how we're going to fill these numbers in. Okay? Alright, so to enter this into your calculator, if you're using the calculators we have in the classroom, okay, the Inspire calculators, with the green buttons, you're going to type in RREF, and that stands for Reduced Row Echelon Form. That's just like a matrix calculation that your calculator is going to do. You don't have to know what it means. You don't have to do anything by hand. You just have to remember to type those letters in, okay? And put that open parentheses. Then you're going to press the menu button on your calculator, select Matrix and Vector, create matrix, and then a grid, or excuse me, a window is going to pop up and it's going to ask you what's the row numbers and what's the column numbers. Okay, that's your dimensions that we came up with. Remember, we have a 4 by 6 matrix this time. You're going to select OK and hit enter, and then you're going to enter in all of those numbers that I underlined and into the grid. After you've done that, you're going to arrow over so that the cursor on your calculator screen is outside of the matrix brackets. A matrix is written like this, where you have all of your numbers in there, whatever they happen to be. Okay, and so whenever you get done entering in your matrix, you have these brackets. Now you will have typed in the letters R, R, E, F, and you would have opened a parentheses. You need to close that parentheses on the outside of your matrix, okay? So that's why you have to arrow over and close your parentheses. Then press the enter button. And when you do that, it's going to give you the answer, okay? We may have to manipulate the answer a little bit, though. Let me talk about that. Okay. Once you enter the grid that we came up with just a minute ago, all those numbers, you enter that into your matrix. We've got that RREF. We've opened and closed the parentheses on the outside of our matrix there, okay? And you hit enter, okay? As soon as you do that, as soon as you hit enter, this is what your calculator is going to give you, okay? Notice that you have some fractions here. Remember, we don't do fractions for our coefficients. So we need to multiply this matrix by the lowest common denominator, which is 3. So you'll see here, I multiply by 3, and that's all you have to do is hit the multiply button, hit 3, and hit enter. And when you do that, this is the new matrix that you're going to get on your screen, okay? The answer, the coefficients, are these numbers right here. Notice that they have negative signs in them. You can ignore that, all right? You cannot ignore putting negative signs in when you are entering the matrix to begin with, but when the answer pops up on your calculator, ignore those negatives. So this is A, this one is B, this one is C, this one is D. And you might be like, okay, well, where's E? We had an E term in there. The last variable will form a diagonal line down the matrix, okay? So I kind of covered that up a little bit. So we're going to get 3 as our value for E because it forms that diagonal line. So our balancing coefficients then are 1, 3, 1, 3, 3, which is exactly the same thing that we got when we did the substitution and the elimination earlier, previously in the video, okay? So the matrix method works. It gives us exactly what we're supposed to get here, okay? Yes, this is a little bit of a setup, but remember when I first taught you how to do algebra method, you were like, oh my god, this is so hard, but now it's the method that like literally all of you use, okay? That's the same thing about this. You need to practice a little bit and get used to it, and this will go so fast and your calculator will do all of the work for you. And as long as you have paid attention and been very careful about entering this, you'll get it right every single time, okay? So the key to doing this matrix method is to write your equations for each element in standard form, okay, and make sure you include every single variable in every single equation. Also, some pitfalls that I've seen here is not typing in RREF. You might forget to do that, or typing it in wrong. If you only put one R, or if you put 2 F's by accident, okay? So it has to be RREF, all right? There is also a menu option. If you hit, menu number 7 is matrix and vectors. If you click on that, there is a selection in there that says reduced row echelon form. You can click that and it'll put the RREF on the screen for you, and then you can go create your matrix inside of it if you're forgetting the letters. So that function is there in the calculator, because you don't necessarily have to remember the RREF, but it's actually just quite a bit faster to just type those in with the green buttons on the calculator. Okay, so that's all I wanted to tell you. Go over a little bit more complex chemical equation, how to balance it with substitution elimination, or what I hope you'll give a try, balancing with this matrix method instead. As always, thank you for learning with me today. I'll see you next time.